Hello students, welcome to our calculation in chemistry series. In today's class, we'll be talking about isotopes and relative abundance. Before we go into the calculations, let's do a bit background knowledge, a brief summary of what isotopes are. So isotopes of an element are atoms of that element that have the same atomic number but different atomic mass. So why is the mass different? All right, so let's say you have isotope of the element carbon, that's carbon 12 and then carbon 14. Now if you look at these elements, remember what we said about the atomic mass. Atomic mass is the sum of the proton plus neutron. So for carbon 12, it means that the proton is 6, the neutron is 6. So how do we, to get in the neutron, what you just simply do is subtract the 6, which is the proton, from the atomic mass. For carbon 14, the proton is 6, the neutron is 8. 14 minus 6 will give us 8. So you can see that the proton is the same, the neutron here are different. So it means that the reason why isotopes have different atomic mass is because of this neutron that is different. Now let's look at how to calculate the relative atomic mass of isotopes from the relative abundance. So here is the formula for calculating it. All right, so let's see, apply that in a question. Question 1 says two isotopes of an element X are 10 and 11. If the relative abundance C is 20% and 80%, find the relative atomic mass. So for X10, the abundance is 20. For X11, the abundance is 80. Now to calculate their atomic mass AR, it is equal to the abundance 20 times 10 plus this 80 times 11, that's the abundancy times the mass, all over 100. So your AR here becomes equals to 20 times 10 is 200 plus 80 times 11 is 880, okay, divided by 100. If you add these two, you are going to get 1080 divided by 100. So your AR here, if you divide this, you are going to get 10.80, which is option A. Another way you can do this is this. For the percentage, let's convert this. Firstly, convert the percentage to decimal. So this is 0.2, this is 0.8. So what you simply do is this. You multiply the abundance in percentage now times the mass. So you just do 0.2 times 0.2 times 10 plus 0.8 times 11. Okay, no need of dividing with 100 in this case. So this will give you 2 plus this will give you 10.8, sorry, 8.8. so if you add them together, you are going to get 10.8. so which is that. So let's take a look at our second example. The question says chlorine consists of two isotopes of mass 35 and 37 in the ratio 3:1 respectively. Calculate the relative abundancy of the isotopes with the mass number 37. So in this question, we are not asked to calculate the relative atomic mass. So we can't use this formula here. We can't use this formula here. Now, rather, we're asked to calculate the relative abundance of the chlorine isotope with a mass number of 37. So how do we do this? So firstly, because it's very easy, So we have two isotopes of chlorine, the one with a mass of 35 and the one with a mass of 37. Their ratio is 3:1. So just add up their ratio, which will give us 4. Alright. So for this chlorine 35, to get the abundancy, you do 3/4 times 100. That will give us 75%. For the other one, we have 1/4 times 100 also. That will give us 25%. So for this chlorine 37, the abundancy is 25. So this is how we get the abundancy. If you decide to use this abundancy to calculate the relative atomic mass, now, although that was not asked, but let's see how we can do that. So for the chlorine 35, let's just quickly convert their percentage to decimal. So this will give us 0.75. This will give us 0.25. So multiply these decimals with the atomic mass. So we have 0.75 times 35 plus 0.25 times 37. So let's use our calculator. So 0.75 times 35, that should give us 26.25 plus 0.25 times 37, so 9.25. So 9.25, you add the both of them, that would give us a 35.5. So I have now used the relative abundancy that I got to calculate the relative atomic mass of the isotope. So there you have it, students. So that is how we calculate on isotopes and relative abundance. So please go ahead, solve some questions, practice more questions, and in the course of practicing, if you have any questions you would maybe that is challenging, you would like me to help you with, I would be in the comment section. You can send it to the comment section and I will be there to assist you. So thank you very much for watching. So if you enjoyed this video, please support us by sharing, by subscribing, and telling your friends about our channel. So do have a lovely day. Bye.